Hi everyone, I'm M.Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Technology. And in this video, I'm going to tell you what is a neural network and its components. So today's topic is a neural network, which is a core idea behind deep learning. So neural networks are inspired by how the human brain works, and this session focuses on basic components, uh, not heavily math. And this slide tells about a small recap of today's session. And artificial intelligence is nothing but make machines think like humans, and machines learn from data, from the past results instead of rules, and deep learning uses neural networks with the many layers. So types of ML are here are supervised learning, unsupervised learning, and reinforcement learning. So why training data matters here is bad data leads to bad model, and good futures of a data set uh, gives a better prediction. See here, classification and regressions are the we're going to done in deep learning. So classification means categorizes like what are the junk mails, what are the mails should be kept in the inbox, and regression is nothing but it's a continuous numerical value such as house protection, gold protection, likewise predictions. And the evaluation matrices are accuracy, precision, recall, and F1 score likewise. Accuracy is nothing but overall correctness, and precision and recall or quality of predictions. F1 score means a balance between them. And this one is to the basic machine learning into the neural networks which power deep learning. So here a neural network is a collection of connected neurons. So each neuron performs a small computation, and together they solve complex problems. So here real life analogy is one neuron is equal to one decision. Many neuron together form as a intelligence. So one neuron is weak, many neuron together are powerful. Then empathy part here. See here, this neural network is inspired by a human brain without any prediction, any rules. And then it made of connector layers and input layer, hidden layer, output layer. Here, learn patterns from data should be in adjusted weights during training, and it is mainly used for to make predictions like classification, regression, and recognition tasks. And the overflow of deep learning working is input data, hit input layer, then there is a number of in hidden layers. The maximum goes up to 1,000 layers, up to our output accuracy. We have to iterate this hidden layer. And the components of neural networks are neuron is nothing but it's a basic processing unit, and it receives the input and produces the output. Here weight and bias are the most important parameter in a neural network, because weight decides the importance of each part, and bias means a certain condition, which means it helps the model fit data better. An activation point, here it adds non-linearity. Example, it uses mainly used of ReLU. ReLU stands for rectified linear unit, and the formula of ReLU is f of x, that is f of x is equal to max of 0 comma x. And sigmoid is already you know about that sigmoid. Sigmoid is nothing but S-shaped curve, and it is mainly used in non-linear functions. And the formula here is 1 by 1 plus e power minus x. This is the sigmoid function. And the another one is Tanh activation function. Tanh, T-A-N-H. This is also one type of activation function. It is mainly used in hyperbolic tangent area, and formula of this tangent activation function is e power x minus e power minus x divided by e power x plus e power minus x. And another one activation function is softmax. In that softmax, it has two types: softmax plus and softmax 1. And last function, while we predicting the value, we must ensure the last function, which means calculating actual minus predicted. This is the last function. Once we receive any error here, then we have to back propagate. Back propagation means once this layer input data, input layer, hidden layer, and then output layer, if there is any error, means we have to back propagate from the output layer to the hidden layer, then input layer. This is called back propagation. That is, updates weight to reduce the error. And the main key point here is output is a predicted value or a class label, and better data set gives a better learning, and it gives the better accuracy. So here in this empathy part, neural network is nothing but inspired by a brain, human brain, without any rules. It learns from data. It should be complex data, and it uses AI tasks. It is mainly used for business analytics, like that. Here, these are already told you about that. What is neuron, what is weight bias, and what are the activation functions. It's present in a deep learning. And here, in neural network, we use these are the classification algorithms: logistic regression, decision tree. That is nothing but root node, then child node, then further divided into child node. Likewise, I have to classify the data. Random forest means two or more decision trees are combined to form a random forest. SVM stands for support vector machine, and it is also the tasks for mainly the classifying the data. Here, then one is K nearest mean it is then it also mainly used for classifying the data, and here the accuracy is measured, and speed versus complexity. Here you have to choose algorithm based on what type of data we used and what is the problem need to choose the algorithm. And your prototype is this by based on these classification algorithm, we have to choose the prototype. And key components, I already told you that neuron is nothing but a basic input unit. And here wait, these are the inputs: I1, I2, I3 and I4. These are the input units, and here the weights are defined as W1 for the I1, W2 for I2, and weight W3 for input 3, and W4 for input 4. Based on this function, this formula Z is equal to I weight plus some condition is bias. So this function is commonly called as f of x. This is the activation function here. I told you about these are the types of activation functions. We commonly used activation function here is a ReLU because of its simplicity and its performance. Most architecture uses this ReLU activation function only. Other than this, we use Sigmoid for logistic regression likewise. Here, real-world applications of neural networks are healthcare, cyber security, sorry, then recommendation systems like Netflix, likewise, and then educational such as speech recognition, NLP, and so social media for sentimental analysis, like that. And summary of today's session is we saw today's class as what is neural network and what are the components in neural network. And neural network is purely inspired by a human brain without explicitly programmed or without any certain set of rules or set there. And it consists of neurons, weight, bias, activation functions, and it can learn patterns through training. It widely used in real world AI applications. And this is the mind map of today's session. We saw what architecture of neural network and key components of neural networks, algorithms such as KNN, decision tree, likewise, and real world applications such as healthcare, NLP, social media analysis, that is sentimental analysis, likewise. And then hope today's class you understand what is neural network and what are the components of neural network. Thank you everyone. Catch you in another video. Bye.